men are seated in a bus and the bus is moving, right? So the 2 men are taking coffee. They are taking coffee and the coffee is not shaking. They are static. They are seated there and they are static. As long as the bus is in constant motion, they are static. And everything they are doing to them is static. But the bus is moving, right? Let's now, for example, say they drop their coffee. Their coffee, as long as it's still in constant motion, their coffee will still be static. It will be shaking until they turn, or there's a turn, or there's anything, there's an alteration, or maybe they can bump into a bump. Then it shakes. But if not, they decide, okay, they have a little ball, let them throw the ball. Then they throw the ball. Let's just say the car is moving at a speed at a speed of 50 kilometers per hour, and then they begin to throw the ball to themselves. The ball goes like this and comes like this. While they're throwing the ball to themselves, right? Let's just say they are throwing the ball at a speed of 15 kilometers per hour, right? So to them, they are only calculating the 15 kilometers per hour which they are throwing the ball, because the ball itself is taking its own motion inside. Why they are static? Remember, they are static, but the ball they are throwing to themselves is taking their own motion inside, right? So now, let's take, for example, there's an observer. The observer is seeing the car moving, and they is seeing 2 people inside throwing things. So the observer's calculation of their speed will now be the speed of the moving car, which is 50 kilometers per hour, plus the speed of the moving ball, which is 15 kilometers per hour. So total kilometer per hour, which the observer will be observing, will be 65. Have you seen how this theory goes? 65 kilometers per hour. We are trying to get the principles of time dilation. Now let's use this as an example. There is a beam. The beam of 2 beams of light. One is going up and down. One was going up and down. Beam A and beam B, right? Beam A was meant to shift. So if beam A is meant to shift towards the speed of light, out far space, right? Beam A will be static, experiencing the speed of light. While beam B will travel a long distance. While beam B travels a long distance, beam B is seen to be smaller, because it's going further. From your observation, beam B is seen to be smaller, but beam B is experiencing a normal reaction, normal motion, normal everything, but it's seen to be smaller. Why it's seen to be smaller is the principles of length contraction. While, okay, beam B begins to experience slower time. And the reason why beam B is experiencing slower time is because beam B is taking a longer distance. Beam A, being stationary, is experiencing the normal time, but beam B's time is going slower. The reason why we are going to say that beam B is experiencing the lower time is for one reason. It's because we are saying that the speed of light of beam A and the speed of light of the beam of light of beam B must be constant. So for speed of light to be constant, something must happen. Their distance apart. And when their distance is apart, their speeds, their time will differ. So that's the principles. So in case this is the formula of time dilation, and then this is the formula of length contraction. So in twin paradox, there's something called twin paradox. 2 twins born the same day. One of them traveled to another planet. Remember, one of them had covered a large distance. One of them traveled to another part of the universe, very, very far, while the other one remains on Earth. When the one that traveled far came back, the one that traveled far appeared to be younger, while the one stationary on Earth appeared to be older. Why? Because the one on Earth is experiencing normal force, while the one that has traveled far, has a slower time. So now you see that we age according to time. We age according to time. That's what they call decay. That's the modern physics. Yes. Because the other one's time is now slower, every reaction in his body automatically will obey the gravity around there and make every reaction to be slower. So now this is all about special relativity. Let us go to general relativity.